Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aziz. So now I want to present about problem statement question 8 population. So the statement is a slow economy caused mega holding annual revenues to drop from RM 888,000 in 2017 to RM 500 to 79,000 in 2020. So the question A is write an equation in the form of AT equal to PQ square T to model mega holding annual revenues after 2017. So the next question is, if the revenue is following an exponential pattern of decline, what is the expected revenue in 2022? So the last question is, how much did the revenue fall between 2018 and 2019?
Greetings. Then I'll present on field table one. In this section, I'm mentioning on four categories. First one is facts, ideas, learning issues, and the last one resources needed. For software facts, based on a problem statement, we can get that the mega holdings and revenue decreased to RM 579,000 in 2020 from RM 888,000 in 2017. And for the second part, the ideas, we can use the equation given A times T equal to PQ power of T to solve the problem. And for the third, okay, for the third scope, the learning issue is how can we use the given equation to solve the problem. And second is how can we find the exponential decline in the term, find the expected revenue in 2022. And for the last part is resources needed. So we use Google Scholar and engineering mathematics book. And the last one is just general web browsing.
Okay, now we go to the solution for this problem. We use AT equal PQT. AT is final value, P for initial value, Q for constant value, and T is time in year. For the question A, AT equal PQT. AT is given 579,000. P is given 888,000. By T, we can find when uh, div- when when 2020 minus 2017, so we can get T is equal 3. So at the question A, we want to find a value of constant value. It is Q. So we get uh, so we assume a value for AT, P and T in the equation AT equal PQT. So we get a 579,000 equal 888,000 Q3. So after that we can get Q equal 0.867. So for the question B, we assume we want to find a value of 80, the final value. So we assume that and get RM 4 $135,019 with 23 cents. For the question C, uh, we minus the 2018 and 2017 and get 1 year. So assume that for a value time in year, and we get answer is RM 769,080 800 and 896. After that, uh, we search for 2019 minus 2017 and get a time in year is 2. After that, we assume in the equation, so we get a answer is RM 667,500. For the final answer, we divide the RM 769,896 minus RM 667,000 and 500, and we get a final answer is RM 763,221.
So problem statement, question 5, Newton law. The statement is on an evening at 6:15 p.m. Vijay put a cup of hot caramel macchiato with an initial temperature of 100 Celsius on a coffee table in his room with an internal temperature of 23 Celsius. Given that the temperature of the drink is 14 Celsius. After 10 minutes is left, what will the temperature of the caramel macchiato be after half an hour? At what time will the temperature of that drink reach 13 Celsius?
Next, I'll presenting on filler table 2 for question 2. So as before, I'll mention on 4 types of categories: facts, ideas, learning issues, and resources needed. For the first one, facts, there's 3 sub anyway, for the first facts is the initial temperature for the macchiato is 120 Celsius. Next, the ambient room temperature is 23 degrees Celsius. And lastly, in 10 minutes, the temperature of the macchiato dropped to 40 degrees Celsius. For the next part, the ideas, the ambient room temperature. And next is finding the rate for change. Finding the rate of change for the heat differences. And lastly is finding the time taken for the drink to reach 30 degrees Celsius. And the third part, learning issues, for the first subsection is how do we calculate the rate of change for the heat changes. And second is based on the rate of changes of the heat, how can we solve the time taken for the macchiato to cool down up to 30 degrees Celsius. And our last category is resources needed. For this part, we use the internet, science textbook, library books, and encyclopedia.
Next, we go for the solution of question 2. We use a equation TT equal TS plus in bracket TO minus TS multiplied by e the power of negative kt. So the given is Ts, that is room temperature. It is given given that is 23 degrees Celsius. For the TO, it is initial temperature, and given that is 100 degrees Celsius. The T in bracket 10 minute, uh, it, given that is 400 degrees Celsius. TT, or the name is final temperature, and the given that is 30 degrees Celsius. So first we find value of K. Uh, we take value of all temperature into the equation. So after that we can get value of K. It is 0.1511. Next, we find a value of T. We take the value of uh, we take the value of given, but we use a final temperature is the 30 degrees Celsius, and we we take a value of K. What we can get before this, uh, into this equation, so we can get a new value of t. It is 50 minute 87 50 minute 52 second. So to get a real time for the temperature of that drink reach 30 degrees Celsius, we plus 10 minute and 5 minute 52 second, and final answer we get 6:40 p.m.
In conclusion, it can be said that population growth may be used to anticipate a variety of outcomes, including the onset of various events and the direction of the economy. Furthermore, it has a multitude of real-world applications. For instance, a company annual statistic might be calculated using the population growth. Using the value obtained, the company may decide how to spend the budget and take activities consistent with their current budget at the time. We may also infer from Newton's law of cooling that when a when a hot object is placed in a room that cools it down, we can predict what temperature will it reach after a specific period of time. To avoid overcooling, you may, for instance, know how long to chill a drink at room temperature.